Kia ora everybody in my physics class, Year 12 Physics 2023, and the chart here will show you that it is the 20th of June. Now for parallel resistors, we've been looking at them, and we know that the reciprocals add up, which looks like a simple formula, but it's actually really hard, because it means that the total amount of resistance we have will be smaller than the smallest one that's there, so it's not instinctive, it's back to front from what we think. Moving along, if I then, in the special case where we only have two resistors, we can consider only two, we might only have two, or we might be only considering two. I might move this thing down a little bit, but every time I do that, something gets moved. We have our total resistance, the reciprocal of it, 1 over RT, is equal to 1 over R1 plus 1 over R2. And then moving along, and that can be manipulated into a nice shortcut, move that face out of the way. And then we can move along here. If I have 1 over the total resistance is 1 over R1 plus 1 over R2, I multiply them both by a 1. And that's a special one. It's a 1. The first one here is R2 over R2. And the second one is R1 over R1, which we know is 1 because it's top and bottom are the same. And we can finish up here with 1 over the total resistance is R2 over R1 R2. And then the other one is R1 over R1 R2. Then because they both have the same denominator, we can add the two top numbers together over one of them. 1 divided by RT is equal to R1 plus R2 over R1 R2. R1 over R2, R1 R2. So there's that one there. There's this one here. And this one here is this one here. And the pluses will work now because we've got the same thing on the bottom. Now we can actually imagine that we've got brackets around R1 plus R2, and we can then find the reciprocal, tumble both sides. We get RT over 1, the reciprocal of both sides, is R1 RT divided by 1, which is just RT. I put the dot, 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 dot. R1 R2 over R1 plus R2, which is for two resistors, is the product over the sum. Then multiply them together over the two added together. So if we look at this one, here's an example. The first example is 6 and a 3. We can do it with 1 over the total is equal to 1 over the 6 plus 1 over the 3. And you'll see the answers 2. But here we have product. We've got 6 times 3 over 6 plus 3, which is equal to 2. And if we did it the other way, we get 1 over 6 plus 1 over 3 is 1 over the total. So that's 1/6 plus 2/6 makes 3/6. So 1 over the total resistance is 1 over 2, and the total resistance is 2. I like this way more. Now we can extend further. We can consider any 2 at a time in any network of 3 or more. So this is one we did in class earlier, 60, 30, and a 20 in parallel. If I consider the top 2 only, the 60 and the 30, I have the total resistance as the product, 60 times 30, 1800, over the 60 plus 30, which is 90. 1800 over 90 is 180 over 9, which is 20. That's cool. That works. Then we can then say, well, at the top 2, we could call them a single resistor of 20. Then, I'll move this thing out of the way. We could have 20 times 20 over 20 plus 20, which is 400 over 40, which is 10. That's the total resistance in a 60, 30, 20. Do it the other way, you'll see it works. Moving along, move this down here. We could also do the 30 and the 20 together. And we would find that we could have 30 times 20, which is 600 over 30 plus 20, which is 50. 600 over 50 is 12. And that's going to give us 12 ohms for the bottom. Then we could do the 60 and the 12 together. 60 times 12 over 60 plus 12 is 720 over 72, which is 10, and that is also the final answer. So that's kind of cool. You can do it the 2 that way. And I'll move this thing probably over here out of the way. And if we come back to here, and in a nutshell, it works. I hope you find that useful. Cheers, everybody.